However, I will say much about ANSYS CFX. These guidelines can be applied for all simulations, not only for CFD simulations, especially for CFD simulations. I present some tips and tricks, but the error estimations and all other aspects can be applied for all kinds of simulations. As we can see, the quality of every CFD simulation is very strongly affected by some errors, and the accuracy of the results strongly depends on the accuracy of the simulation model. So every model contains uncertainties and errors, and in this presentation I will give you a little bit more information about these errors, to make you sensible for these errors, to minimize these errors. We always have these two facts to take in account: the level of accuracy which is needed for the simulation and our simulation goal. Because depending on the simulation goal, we need a different accuracy. If you only do design studies, we won't need the same level of accuracy as we have to take into account if we do safety analysis. So the first starting point is always to identify possible error sources and minimize them. So this is the motivation for this topic, and I want to make you a little bit more sensible for examination of numerical models, because this is a very big topic always for numericals, to compare the results with the model itself. There are different types of errors, and every model contains different uncertainties and errors, and the result is always affected by these errors. Not only by one error, mostly by different errors in sum. We have here the numerical errors. The numerical errors are round-off errors, iteration errors, spatial discretization of the model volume, and the temporal discretization. The second error type are model errors. Model errors are errors in the special models, for example, turbulence models, multi-phase models, material models, and so on. The third type are user errors. These are the errors which are introduced by the user. Normally these errors couldn't be neglected. They are important. How experienced is the user? How good is the project management during the simulation? If all errors vanish, you always have these errors, and as you attend this conference, you try to minimize them, because you collect more experience, and every year or every simulation you make, you collect experience, and how more experience you have, then a better accuracy would be in your model normally. The fourth type are application uncertainties. These are not directly related to the simulation model itself, but these are uncertainties of the application. What are applicable boundary conditions? What are the special physics of my model, of my situation I want to model? And I think these both play together. If you have a good experience, I think you can you have a higher chance to understand the physics. Yeah. And last but not least, there are software errors. And if you use ANSYS, the software errors are minimized because there's a good quality management during ANSYS. In every release, we have different examples which are calculated by the company ANSYS to verify the solution code. And if there occurs some errors, there are there are always error reports to give information to the user, and so I always suggest to use commercial software codes because of support and quality management. So these were the types, the error types, and beside these different types, we have different sources of error. Yeah, there are several sources of error. I have ordered here these in order of magnitude.